In this video, I want to talk about the basics of recognizing quadratic functions. These are of the form y equal to ax squared plus bx plus c, where a, b, and c are numbers, and a is not equal to 0. When we talked about linear functions in a previous video, we talked about how they had a constant rate of change. Quadratic functions don't have a constant rate of change, but they do have a pattern. They have a constant change in the change. So let's look at an example to see if we can understand how this works. For this example, if I look at my rates of change, the first one would be 3 over 1, which is 3. The second one, 5 over 1. My next one, 7 over 1, and then finally 9 over 1. So this is definitely not a constant rate of change. However, if I look at the change in the changes, this has a plus 2 to get from 3 to 5. 5 to 7 is plus 2, and 7 to 9 is plus 2. So the fact that this right here is constant tells me that this is a quadratic function. Let's look at another one. Here, all of my changes in x are plus 1. So I'll be dividing by 1 each time. In my y, from 1 to 6 is plus 5. 6 to 15 is adding 9. 15 to 28 adds 13. And 28 to 45 adds 17. Looking at the changes in the change, this would be plus 4 to get from 5 to 9. 9 to 13 is 4, and 13 to 17 is 4. So this would be quadratic since the change in the change is constant. Quadratic functions are very helpful to model the height of an object that is falling. The change in distance of something falling is known as velocity. And the change in velocity is known as acceleration. When we're looking at an object falling, the acceleration is just gravity. And since gravity is constant, that means the change in the change is constant. So this would be modeled by a quadratic function.